Good morning. My name is Daniel, and I really appreciate you and thank you for the invite to be able to show a demo class in AP Physics. I teach AP Physics, I teach IB Physics, and GSC Physics. And presently, I am an independent contractor with Wedo Education in Vancouver, Canada. Today, I'll quickly go through this brief topic, which is one of the topics in AP Physics, which is resistivity and conductivity. Due to the limited time that I have, I will be able to talk about some certain things concerning the topic. The learning objectives are the students should be able to explain what electrical resistance means at the end of the topic. You should be able to state the factors that affect the electrical resistance. You should be able to derive the equations connecting resistance and the factors listed above. And also, you should be able to explain resistivity and conductivity. Before I go ahead, resistivity is just a word that is coined out from, it's a word that is coined out from resistance. I mean, when we talk about resistivity, this resistivity is a word coined out from resistance, and it is an English word, resistance, to be able to resist. Resistivity is very, very important in electrical industries in the making of various electrical wires of different diameters, because various electrical appliances have they have some specific voltage rating that they operate on, and which one of the factors is the resistance of the wire that are used in constructing those devices. Now let us look at the definition of resistance. Resistance can be defined as the opposition. This was what I said earlier on, the opposition offered by a resistor, okay, to the flow of electric charges or electrons or current in an insulator. So meaning that various electrical conductors have their rate of resistance. They have their, how shall I put it, the rate at which they oppose the flow of electric current to pass through them. Okay, and these factors are that determine the electrical resistance of a conductor are: one, the length of the conductor is very, very important. The second one is the area of the conductor, that is a cross-sectional area of the conductor. In various offices, we have computer systems, we have laptops, we have scanners, we have various devices that have wires connected to them, which are the electrical conductors. If you look through these wires, you will discover that these wires have various diameters. Okay, so these diameters is the area. This area is depends on the resistance of a conductor. We have the temperature of the conductor, and we also have the nature or the type of the material. So in summary, the four basic factors that affect the electrical resistance of wires, or let me say conductors, are the length, the cross-sectional area, the temperature, and the type of material that the wire or conductor is made of. Now, how does the length of a conductor affect its resistance? From what we have here, the length of a conductor is directly proportional to the electrical resistance. So this means that if the length of a material increases, then the resistance of that material also will increase, meaning that there is a direct relationship between the electrical resistance of a conductor and the length of that conductor. Say for instance, if the length of the conductor is is 2 meters. Okay, I don't want to use centimeters now because meters is a fundamental unit, which is part of the topics that we have in AP Physics on units and measurements. Now, let's say the resistance of the material was 2 ohms at that length, okay, was 2 ohms at that length. So if the length of the material increases to say 5 meters, okay, then the resistance of the material also will also increase uniformly, say to about maybe 4.5 ohms, okay, to about 4.5 ohms or so. So that is that for the length of a conductor. You should have it at the back of your mind. It's not only when the length of the conductor increases. If the length of the conductor reduces as well, then the resistance of the material will reduce. But for area of the conductor, the area of the conductor, there is an inverse relationship between the resistance of a conductor and its cross-sectional area. So the opposite is the case, the reverse is the case. If the area of a conductor, let me say the thickness of a wire, if we have a large wire with a very big thickness, it goes to tell us that since the area is large, then the electrical resistance will be smaller because there is an inverse relationship between the area of the conductor and the electrical resistance of the conductor. So, and these wires, you can see them, maybe wires that bring electricity from the power line or from a transformer. When we check or you look through the thickness of the diameter, thickness of these conductors, you will discover that they are larger. They are larger in the sense that they will allow let me say, a smaller amount of electric current to pass through them. What I mean is, now, if the area is large, the resistance of the wire will be small, okay, giving a large amount or large value of electric current to be able to flow through that wire. So that is why when the thicknesses of the electrical conductors, wires from transformers or from power lines, when it is checked, they are usually larger. But on getting to our various homes, you will discover that these wires, their thicknesses will reduce. Yes, their thicknesses will reduce because our various appliances at home, the amount of voltage, or let me say their voltage rating, is smaller. So definitely they need little amount of electric current. So invariably, lower cross-sectional area will make the electrical conductor to have a larger resistance, making it difficult for larger amount of electric current to flow through. The others are the temperature of the wire, which has the same relationship to that of the length. The temperature of a conductor is directly proportional to the electrical resistance, meaning that when the temperature of the electrical resistance increases, here the temperature, okay, and the electrical resistance, there is a direct relationship between the two of them. So similar case for length. If the temperature increases, the resistance of that electrical conductor will increase. And finally, the type of material that the conductor is made up of. We have various types of materials that conductors are made up of. Okay, some are largely good conductors, while some are not all that good conductors. So since these materials, their nature, okay, vary from one particular conductor to the other, then definitely their resistance also will vary. I cannot but run through so many. These are the equations connecting the resistance, okay, and the area, okay, of the resistance and the cross-sectional area of a conductor. This is the resistance. You see that there is an inverse relationship, and this is the formula connecting the whole factors that I have mentioned earlier on. Okay, so I would like us to quickly go through what we have done. I started by telling you that we want to talk about resistance, that most materials, okay, material wires have various level of resistance. They have a way they can allow electricity to pass through them, and some will allow large amount while some will allow lower amount. And I was only able to talk, because of time, explain what electrical resistance is and the factors that affect the electrical resistance, which are the length of the conductor, the area of the conductor, the temperature of the conductor, and the nature of the conductor. The relationship between the length and the resistance of a conductor is a direct relationship. If the length of the conductor increases from 2 to 5, the resistance also will increase. Similarly for temperature, okay, but cross-sectional area, there is an inverse relationship between the electrical resistance of a material and its cross-sectional area. So there are various more to discuss on this topic. I would like, if and let me an offer is created, I will be able to discuss deeply, okay, how these factors, okay, are applied in various industries, especially in the electrical industries, in making of wires and in making of electrical resistances, making of electrical wires and electrical devices. So just to say, so I would appreciate if you can DM me, then we'll be able to talk better. Thank you.